Well, let me start off and say thank you for taking the time to attend today's presentation. My name is Lance Zurich, and I'm the product manager for the Fisher Technic Education Division over here at Studica. And of course, today we're going to take a look at the newest releases in the Fisher Technic line of simulation models, that being the Agile Production Simulation model and some of its add-ons, the Agile Production Simulation, which we will sometimes refer to as APS. The new model is designed to demonstrate how the current challenges being faced in production and logistics planning can be addressed, and it's designed to incorporate the best features of some of the previous Fisher Technic models, along with many new cutting-edge innovations. So we'll kind of go through that. So before we dive into the meat of the presentation, I'm just going to provide you with a little bit of background on Fisher Technic and its products. The model we're examining today is once again the newest addition to the Fisher Technic line of industrial simulation and training models. Now, these models in the line have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line consists of a series of pre-assembled small-scale models which were designed to replicate both in appearance and function various automated robotic machines and systems that you would commonly find used in commercial manufacturing processes. The Fisher Technic company has been creating tools for teaching students of all ages how technology works for 60 years now, all based around their unique building system. Now, what makes the system unique is that unlike other popular construction systems where the components are designed to simply stack, in the Fisher Technic system, it was designed with more of an engineering mindset, all based around a core building block that allows attachment from all six sides. And because of this, it really allows you almost limitless design possibilities. The parts are generally designed to slide together and lock in place using a tongue and groove assembly method, and there are hundreds of different parts, very specific parts, that will allow technical builders to address equally specific design needs. The system itself was created back in the 1960s by German inventor Arthur Fischer, who's noted for countless innovations used in both construction and the automotive industries. At the time of his death in 2016, Mr. Fisher held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Just to give you an idea, prior to creating Fisher Technic, Mr. Fisher was first noted as the inventor of synchronized flash photography, and this was back in 1949. And a few years later, he gained fame as the creator of the expanding nylon wall plug, which is commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fisher Group, continues to employ thousands of workers all around the globe, producing many variations of fastening devices used in building construction. And up until very recently, they also produced many components used in the automobile assembly process. And currently, they're involved in providing also consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, for those of you who are familiar with the Fisher Technic line of construction sets, uh, the focus of those sets, there's both a retail line and there's an educational line. But either way, the focus has always been on helping to foster an understanding of technology. Now, the sets designed for use in the education sector, which are a lot of what we deal with here, are most often focused on a specific subject area that falls under the area of what we would, or the umbrella of what we now call STEM education. And these would be sets that address topic areas such as mechanics, pneumatics, robotics, renewable energies, things of this nature. And typically, when you're using these sets, students are going to be asked to build a progression of different models, all using, of course, the Fisher Technic building system. And then they perform various experiments, which allows them to explore and understand key aspects of that particular subject area. Now, getting back to the Fisher Technic simulation solutions, which are, of course, going to be the focus of presentation today, these are something, again, different, much different. The line consists not of kits, but again, these are pre-assembled small-scale models to replicate in both appearance and function various automated robotic machines and systems. Now, some of the things that you will find in the complete line, which again, we're not going to really look at today, but in the line, you'll find things like conveyor belts, punching machines, three-axis pick-and-place robotic arms, color sorting lines, and even high bay warehouse storage systems. Now, besides these individual models which focus on specific automated processes, Fisher Technic also offers numerous variations of an integrated factory simulation model. In the factory simulation model, typically there are going to be four more individual workstations. Most often, you're going to see a vacuum gripper robot, a high bay warehouse storage system, a multi-processing station with an oven, and a sorting line with color detection. And these are all designed to work together as one self-contained material cycle. Other variations of the factory will focus on the idea of Factory 4.0, utilizing IoT in the form of controlling and monitoring the actions of the factory from a web-based dashboard. Now, as we have a full-scale webinar presentation discussing each of these models in the line in detail and providing video and what have you, we're of course not going to touch on them here, but I would of course strongly urge you to attend one of those presentations if that's something you'd like to know more about. Or of course, you can reach out to me for more information if you'd like. But before we begin the overview of the new Agile Production Simulation model, I'm going to very briefly outline some of the advantages of using Fisher Technic solutions like we're looking at today. First off, Fisher Technic simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding, again, various aspects of automation and programming. Now, this could be for understanding how automated systems work, or just for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models, once again, are designed to realistically replicate in both appearance and function common automated systems, things like, again, conveyor belts, sorting machines, robotic arms, and so on. Because of the compact size, they are not only ideal for use in the classroom or in office demonstrations, but also for demonstrating software or other technology-based offerings in, for example, a trade show environment. The next factor, and an extremely important one, is quality. Each Fisher Technic simulation model is a hand-assembled, high-quality German-made product. The majority of the models in the Fisher Technic simulation line, including, of course, the Agile Production Simulation model, which we're going to be looking at today, most of these models are designed to be 24-volt models, which are designed specifically for use with the latest industrial standard PLCs. Now, while the APS model we're going to look at today already includes all the PLCs and necessary components within the scope of delivery, other Fisher Technic 24-volt models can be controlled using the PLC of your choice. In this case, again, everything is included. The programming is also something that you have options for with the rest of the line. Again, we're going to be looking at a pre-programmed model today, but for those of you who wanted to, let's say, program with, LD or ST or whatever, you can use the various programming formats for that. The final thing is Fisher Technic simulation models are cost effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation options that are available in the marketplace, you'll quickly notice that the entry point for many of these items can be quite high. Now, Fisher Technic simulation solutions, on the other hand, start off at just a fraction of that price. They're relatively low. There are models that are around $1,100, $1,500. And again, there are also compact, realistic, and high-quality learning and demonstration tools. And again, while admittedly the APS model we're going to look at is definitely on the high end of the Fisher Technic simulation product range, it still offers significant value in terms of what it allows you to address for a still very reasonable price point, still a fraction of what, some of these other things are going to be available. And you'd be likely hard pressed to find a truly comparable solution to the APS available anywhere. So with that being said, let's now move our discussion specifically to the Agile Production Simulation model and discuss what the term Agile Production means and why this is important. Now, here's a slide that I've used in several of the other Fisher Technic webinars we present, and it shows an early version of the Henry Ford style production line model. The Ford production line was, in its own time, a very innovative thing in that it streamlined production back in a time when the focus was on efficiently producing a large quantity of the exact same thing. Of course, in the case of the Ford production line, workers along the assembly line each focused only on a very specific part of the automobile production process. For example, maybe they focused on installing a specific component or making a specific adjustment before the vehicle was moved further along the production line, where the next worker in line would perform the specific task that they were being charged with, and so on and so forth until the assembly of each of these models or automobiles in this case was completed. Again, when the goal was to produce a large quantity of the same thing, this worked really well. Of course, things are no longer quite so simple and with very good reason. Product customization must be considered, as well as the large numbers of assemblies and components that need to be used. Likewise, the increase in customization options which are available just complicates things further. Product life cycles are also much shorter now, with an increase in overlapping product launches and production mix. And flexible manufacturing requires an increase in logistics processes. So to summarize, industry must now deal with smaller batch sizes during the production process and increasingly complex product processes. Now, this requires companies to better synchronize production and logistics, and also to make investments in cutting-edge automation and processes, and to be as efficient as they possibly can. For example, consider the production of a modern automobile, such as the BMW 3 Series, which is shown here. The manufacturing process must be set up to efficiently and cost-effectively address the 18 different engine options available to consumers, as well as the 5 different equipment packages and 70 different individual equipment options. Now, clearly the old school Henry Ford style assembly line, which again was designed to quickly produce a high quantity of a single specific model, simply is not going to work anymore. And so it's with this in mind that industry has increasingly transitioned from the assembly line production method, with its rigidity and constraints, to methods such as the matrix production model, which eliminates the fixed time cycle and sequence of processes, or fluid production models, which also allow for an unlimited number of assembly scopes per station. The most notable benefits of incorporating such agile production methods are in the area of flexibility, including the increased flexibility in production processes, being able to offer customers specific mass production while avoiding overcapacity, and also reducing lead time through a mix of different derivatives. An additional benefit is being able to produce goods as specifically dictated by the wants and needs of your customers. And this is why Fisher Technic created the new Agile Production Simulation, which again is the latest version of the factory model that I touched on before, but this time not only incorporating IoT and state-of-the-art manufacturing processes, but also an element of AI, which we'll talk about. In addition, this innovative new model also includes a digital learning platform. And here's a quick look at the full factory. Now, as we've just seen, forward-thinking companies rely on automation, modularity, artificial intelligence or AI, and agility, all to remain competitive. In order to promote these topics in industry and research, students, apprentices, and employees each require the corresponding know-how and awareness to enable them to deal with these complex issues. And this is where the Fisher Technic Agile Simulation model comes in. It's been designed to simulate processes such as quality assurance using artificial intelligence, the functioning of driverless transport systems, and to replicate automated processes on a small scale, from the receipt of goods into the system to modular production to quality assurance. The model includes several features not previously available in the Fisher Technic simulation line, including an automated guided vehicle and a 6-axis robot. These are both innovations to the Fisher Technic line. The accompanying didactic material also helps to translate the hands-on simulated processes into future skills for both students and teachers. And in addition, the digital twin of the model helps to significantly intensify the learning experience. Now, as we're still awaiting the release of a fully narrated video for the APS model, which we do have for some of the other ones. This is still in production. What I'm going to do right now is I'm going to provide you with a little bit of an overview of each of the workstations or modules as I present these slides. And we're going to start off with the section which you see here, which is where incoming and outgoing goods are placed. And this is essentially where the material flow of the workpiece in the factory system will begin and end. What happens here is the raw material is delivered at the goods receipt slot. It's positioned on the color sensor for quality control, which is done by the six-axis robotic arm with a vacuum gripper, and it's encoded on the NFC reader. The six-axis robot then takes the workpiece and places it on the automated guided vehicle, which I will probably refer to as the AGV moving forward, and it's put onto the AGV for further transport to the various workstations. Now, this module will also contain, this is being the module we were just looking at, also contains the central control unit, which is a Raspberry Pi, and it has the environmental sensor, which measures the different environmental conditions that are going on in the factory. There's also an integrated movable camera which can be swiveled in two axes and provides an insight into the entire factory via the Fisher Technic cloud-based dashboard. And at the end of basically of a work cycle, a finished workpiece is delivered back to the goods dispatch by the AGV. So again, the AGV will take the workpiece from this entry point, and eventually, after it's gone through the stations, the AGV will bring it back for distribution or wherever it needs to go to. Now, typically from that entry point, the next stop for a workpiece after this goods receipt is usually the high bay warehouse. Although, again, because this is an agile production simulation, the order of processes can be changed if there's a need for doing so, or the order of process, or omitting certain processes per se. But in any case, let's assume that it goes to the high bay warehouse first. So the high bay warehouse contains 9 slots for workpieces. It has a stacker crane of its own and a vacuum gripper of its own that picks up the workpiece from the AGV at the docking station of this model and hands it over to the stacker crane for storage. Then what would happen is the workpiece is placed in a workpiece carrier tray, and its retrieval is done according to the first in, first out principle. So basically, once the AGV delivers the workpiece, the little vacuum gripper at this station picks up the piece, puts it in the tray, the crane moves it to the correct slot where it needs to be stored, and that's the way that works. The next model we're going to look at, or the next station and module, I should say, is the drilling station. The drilling station, like the other workstation, consists of a docking station for the AGV to come up to. It has its own vacuum gripper that places the workpiece from the AGV onto a conveyor belt, where it is then transported under the drilling head. After the simulated drilling process takes place, the workpiece is then transported back to the gripper on the conveyor belt, and then the gripper model, or the gripper arm, will then place the workpiece back into the AGV. Next up would be the milling station. And I will mention as a side note, as I haven't touched on it before in the presentation, you will note that when you see the images of these various modules, that that you're going to see that there's also a Siemens S7 1200 PLC, which has been pre-wired to each of these, and also this has all been pre-programmed. I'm just going to mention it now. We're going to touch on it later, but you will notice as you see these, each of the individual workstations has its own PLC. So continuing along, the milling station consists of a docking station, again, for the AGV to come up to, and it again has a vacuum gripper that will take the workpiece from the AGV, place it onto a conveyor belt, where it is transported, in this case, under the milling machine. There, the milling of 2 pockets on the workpiece is simulated, and after this process occurs, the workpiece is placed back onto the conveyor belt at this station and transported back to the gripper robot, which again will move this piece back to the AGV. And next up is going to be the quality control with AI module. Now, in the quality control module, a vacuum gripper, again at the station, takes the workpiece from the AGV, places it onto its own conveyor belt, where it is transported under a camera and scanned there. The work pieces, which we haven't touched on before, but they come in three different colors, red, white, and blue, and they also have three different machining features on them, drilling, milling, or drilling and milling, as well as various fault patterns. And the work pieces basically are scanned by the camera, and they're classified using the trained AI. Now, depending on the color, the feature, or the fault pattern that may exist on the workpiece, the workpieces are either placed back onto the AGV as being okay, acceptable pieces for further movement, or they're sent to the reject container as not okay or defective. At this point, just to provide a little more information on the AGV, which has been moving all of these pieces around the workstations, it's of course it's controlled by a Fisher Technic Robotics TXT 4.0 controller, which has been pre-programmed using Python. It's a track-bound vehicle that follows along the printed black tracks that are on the floor of the APS factory, and it uses ultrasonic sensors to detect obstacles that may be in its way. The vehicle has omni wheels, which allow it to move in all directions. Two buttons and a photo transistor help the vehicle dock to the individual factory modules. And the AGV receives its driving commands from the central control unit, which is an industrial standard VDE 5050, and it uses a Fisher Technic rechargeable battery pack as its power supply. And since we're talking about power supply, this brings up the charging station. When the battery of the AGV runs low, the AGV will navigate towards the charging dock where it is automatically charged with the charger with charge monitoring. Contacts on the bottom of the charging station connect with the AGV with the charging electronics. So moving right along, we're just going to very quickly review some of the technical specifications. It is, of course, a 24-volt power supply unit, 11 amps. The central control is from a Raspberry Pi 4B. The individual modules, as I touched on before, are controlled with the help of 5 SPS Siemens S7 1200 PLCs. So each of those 5 modules has its own PLC. Additionally, the model includes 3 Fisher Technic TXT 4.0 controllers, which are used to control the sensors and the camera, as well as to facilitate cloud access and the WEWA module for quality assurance with AI, and also for the automated guided vehicles we touched on. There is a WLAN router for WLAN network. Software used on the APS model includes SPS programs, structured text, which are for the PLCs. There is TypeScript for central control of the Raspberry Pi, Node-RED for communication between SPS and the Fisher Technic TXT 4.0 controller. There's Python for programs on the TXT 4.0 controllers, and TensorFlow is used for supervised learning and quality assurance with AI in the quality assurance module. Additionally, like the most recent versions of Fisher Technic Training Factory discussed in our other webinar, the APS model has a cloud-based dashboard which can be used for order control and monitoring of the factory status, as well as for determining key figures. The factory itself can be broken down into sections which utilize an easy put together tongue and groove assembly like giant puzzle pieces. Now, when assembled, the Agile Production Simulation model has a footprint of approximately 51 by 71 inches, and you're looking at a total weight of approximately 116 pounds for the factory itself. A storage case is also available separately for protecting the modules, the model, and all of these individual models when not in use or when being transported. And we're, of course, going to look at that shortly. And as well as I've touched on, there are didactic materials which are also included, and that's all downloadable from the Fisher Technic website. Now, as I mentioned earlier in the production or in the presentation, we're still waiting the completion of a narrated video of the factory in motion, but while that isn't available at this time, I would like to share with you some raw video we have of the factory in operation. And you'll see it going through the motion of the various steps that I touched upon earlier. So let's just kind of start that off. Here, of course, you see the AGV as it's moving along the track, black printed track that's on the base of the APS model. There you get a little bit of a look at the AGV, the TXT controller. And here it is docking with the first station where the pieces are, of course, enter the process. See another version of the docking. The camera. The router previously, sorry. That's the module that takes senses the temperature, the lighting, the air quality, things of that nature. Here you have a workpiece being entered into the station where it's going to get scanned by the NFC reader, entered into the system. Once it has been, the 6-axis robotic arm, which has it with the vacuum gripper right now, is going to take that piece and it's going to move it onto the AGV in one of those little slots in the back, which you'll see happening here. And there you go. And then you see the AGV is going to move to its next station, which in this case, like we talked about before, is going to be the high bay storage warehouse, where the high bay storage warehouse has its own vacuum gripper, which is going to pick up the workpiece, move it in place where the stacker crane can, with the workpiece carrier tray, can grab the piece and store it in one of the slots. And this is also where another piece could be grabbed for further processing. So here it is, a version of the web-based dashboard where you can see where a customer could order a work piece, or you can see what work pieces are in stock or what have you. So anyway, hypothetically, a customer has ordered a work piece, it's retrieved from the high bay warehouse, and kind of a reverse of the process we just saw, where the arm with the vacuum gripper would move it back onto the AGV, where here would go on for further processing. And this would be, whether it be the milling or the drilling station. I don't believe it's going to show both here. I believe it only shows one, but it's essentially a variation of the same process. So yeah, here it looks like we have the mill or the drilling station. So again, you see the gripper arm at that station picks up the piece from the AGV, puts it on the conveyor belt. The process is being simulated. Here's a version of the milling process instead being done. Again, you see the Siemens PLCs that are connected to each of these modules. Again, pre-programmed, this all comes with it. The AGV moves along to its next station. In this case, this should be quality assurance, I believe, and it is. Again, like before, the vacuum gripper at that station picks up the workpiece from the AGV, puts it onto the conveyor. In this case, it's scanned by the camera, and it's classified depending whether it's defective like that one, in which case it's rejected, or otherwise it's put back onto the AGV for movement to the next workstation or for storage. In this case, it goes to the process where it's again scanned, that everything has been done, and it's ready for pickup. And here you have the AGV going to recharge. And here you see how the pieces of the APS model come apart, so they can again be stored in the case or wherever. So moving right along, another very important aspect of the APS model, which I touched upon, is the inclusion of a digital learning platform. The digital learning platform is a high-performance, immersive learning experience, and it's based on a digital twin of the Agile Production Simulation model. And it really serves as the educational counterpart of the physical factory model. The learning tool is used to clearly illustrate the control units, the actuators, and the sensors included on the model, and to demonstrate the full functionality of the APS. The platform offers interactive learning modules on agile manufacturing, IoT or Internet of Things, AI, and automation. It enables the simulation and evaluation of highly complex process workflows in agile manufacturing. The digital learning platform is a byproduct of the partnership between Fisher Technic GmbH and the Karlsruhe Institute of Technology, the prestigious public research university located in Karlsruhe, Germany. And please note that there are no additional costs or fees associated with the digital learning platform. It's included in the scope of delivery when you purchase the APS. Now, to give you a better idea, this page helps to illustrate the structure of what is covered by the digital learning platform. Now, as you can see here, users start with an introduction to the Agile Production Simulation, and this begins with an interactive explanation of each of the process modules, as well as of the control units, the actuators, and the sensors. Following this, the main instruction is broken up into four separate modules, one which is focused on agile manufacturing, the second on the Internet of Things, or IoT, the third on artificial intelligence, and the last on automation. Each unit or learning module will include the following: a theory section, which establishes a fundamental understanding of the topic at hand, a practice section, and this is where users can simulate and understand the processes being studied with both the physical mode and the digital twin version, and transferability, where students get to see how the knowledge they've acquired can be used in the real world. Here are some screen captures of the digital learning platform to provide a better idea of what this is all about. The digital twin forms the foundation of the digital learning platform. Once again, the educational or exploration mode of the APS is implemented using the digital twin. The digital twin can be utilized to solve tasks in the learning modules, and the digital twin can be used to simulate complex challenges in an agile production environment. Just going to click through some of the slides here.
There are four different learning modules: Agile Production,
Now you will see there are a lot of tools with the DLP, including the Workflow Planner tool and an analysis tool as well. Now, if you want to delve further into this, you can do so easily by simply emailing me, and I'll provide my contact info at the end of this presentation, and I'll be happy to send you a link to the specific section of the manufacturer's website where more detailed information and system requirements are posted. And I believe you can also access the the digital learning platform, at least on a review process. You are able to do so. So if you'd like to do so, I can get you that information. So flexible, modular, agile, and connected. This is the Fisher Technic Agile Production Simulation model. The APS model is the perfect tool to use in higher education, for advanced CTE training, university labs, and of course for industrial training. It's an ideal tool for teaching about the future of production, and it offers a hands-on learning experience. It provides a safe method for teaching these skills while also offering a tool that replicates, again, both in appearance and function, those that would be used in industry. It provides a bird's eye view of a working factory, and of course, it offers considerable added value with the digital learning platform. It's ideal for demonstration purposes for companies involved in areas such as IoT and software development, as well as consulting. In addition to the APS factory itself, there are now two add-on modules which can also be incorporated if one wishes to expand the functionality of the model. The additional annealing furnace production module unlocks more learning content in the digital learning platform. Both theory modules and additional tasks in the Agile Production Learning module are made available. These cover topics such as introducing new derivatives into production and expanding existing production configurations with an additional process. The module, like most of the modules of the APS, includes its own Siemens S7 1200 PLC, which has been pre-programmed the APS model, and not for use as a freestanding model like other Fisher Technic models would be. The second add-on available for purchase, as I touched upon earlier, is an additional AGV, which can also be added to your model. Now, like the annealing furnace, the add-on automated guided vehicle also unlocks access to further learning content in the digital learning platform. Both theory modules and additional tasks in the Agile Manufacturing Learning module are made available, and these will focus on Agile intralogistics as well as the parallelization and prioritization of the production workflow. The model ships with a pre-programmed Fisher Technic Robotics TXT 4.0 controller, as with the version included with the APS, the programming has all been done in Python. This, of course, can only be used in combination with the APS model, and again, it's not intended as a freestanding use model. The dimensions of the model are approximately 10 by 7 by 5.5 inches, and it has a weight of about 3.15 pounds. So that pretty much concludes the main portion of the overview of the Fisher Technic Agile Production Simulation model. So now let's briefly review the cost for each of these items. The Agile Production Simulation model itself, including 5 Siemens S7 1200 PLCs and 3 Fisher Technic TXT 4.0 controllers, and again, also access to the digital learning platform with a digital twin. The cost for this is currently $28,174.95. This may be changing as the tariffs start to affect us, so if you can get it while it's still in stock, this is the price you would be paying. The APS add-on module annealing furnace, which again includes its own Siemens S7 1200 PLC and also unlocks additional didactic content in the digital learning platform. Your cost for this is $3,859.95. The additional automated guided vehicle, which can be purchased, which again unlocks additional content in the digital learning platform. The cost for this is $2,249.95. And as I touched upon before, there is the storage case, the storage and transport case designed especially for the Agile Production Simulation model. As the APS model is obviously a substantial investment, this is a great option to help protect the model when not in use, and of course, when you need to transport it safely. It's a two-tier aluminum case with foam inlays to protect the individual workstation models. Each of the two sections, each of the case has steel-tilt handles and angle protection corners for additional stability. Overall, it's an aluminum case maker profile with plastic plates. There are also straps and internal zipper pockets for storing cables, cords, workpieces, and other accessories. The lower section of each case is lined with hard foam, while the upper sections have some foam to help cushion the various work modules while they're in storage. The dimensions of the case are approximately 48 by 32 by 29 inches. It has a weight of approximately 75 pounds unloaded. And when the APS model is loaded into the case, the total weight is approximately 190 pounds. Uh, Please note that even when the model is being kept in the storage case, if you are transporting this model, it should always be shipped flat and always shipped as freight on a pallet. This is not something you would ever send via UPS or FedEx. It's just too big. And again, the cost for the storage case is $4,024.95. Again, some of this is subject to change as we go through the stock. We did stock up before all of the tariffs went into place, but again, that's only going to hold for so long. So know that this is, if you want to get in on these costs, this would be the time to do it. So on this point, if there are any questions, you will be able to use those chat windows, the webinar chat window, the question and answer window, which can be found on the Zoom toolbar. So if you did have anything, I will look to see if you're typing. So if not, I will just keep talking if you'd like to take the next step. So if you would like to request the full color 2025 Fisher Technic Higher Education Industry Guide that basically goes over the APS model that I've talked about today, it also goes over the specifications and details on all of the other models that are currently available in the Fisher Technic line. You can do so, request that from us. If you'd like to request a quote for this model or for any of the Fisher Technic items, if you'd like to speak with your dedicated educational representative, or if you want to speak with me, all you have to do is call us here 888-561-7521. General quotes and inquiry for materials and what have you, you can just email us at info at Studica, Studica.com. Or if you have anything specific for me that I may have talked about today that you wish I mentioned, or any questions about any of the other products in the Fisher Technic simulation line, you can also email me directly, and that would be lance.zurek, lance.zurek @Studica.com. So, on that note, thank you again for taking the time to attend today's presentation. We look forward to hearing from you soon. Have a great afternoon.